So welcome to FUNNYMATH page. We still continue with the BECE episode. This is going to be the next set of questions. So now let's go through the scope of these questions and see how we can solve them. Now this is the first question. That's question 1A. The table below shows information about the ages of 24 students. These are the ages in years and the number of students. So 16 years, they are 9, 17, they are 3, 18, and out of 19. Now these are the questions that we have to answer. We have to find for the ages above the following: the mode, the ages, the median of the ages, and the mean of the ages. So how do we go about this? Let's begin. Since there's a table form and we have to find the median and also the mean from this frequency distribution table, I'm going to redraw the table here and that will make your work easier. So now let's see how we're going to do that one. So this is how we are going to redraw the frequency distribution table. So this column is going to be for the ages. So the ages, we normally call this one X, the X values, and the number of students, which is also called the frequency. So I'm using frequency here. So frequency, we can use small letter F for that. And this column is going to be for the product of the frequencies and the ages, and we call that one Fx. So we have Fx here. That means you're going to multiply the frequency by the X values. So now these are the ages. We have 16, the next one is 17, we have 18, the last one is 19. Also, these are the corresponding frequencies. There are 9 students who are aged 16. So we have 9 here, 3, 8, and 19 years, they are also 4. So you're going to get the f of x, that means the product of the f and that of the x. So 16 by 9, that's going to be 144. We have 444 here. And 17 by 3, that is 51. 18 by 8, we have another 144. 19 by 4, we have 76 here. Now you see I left some portions here, and they are for the sum of these numbers. So when you take the frequencies, we're going to add all of them to get what we call the sigma f. This symbol. Let me get my sigma. Well, so we have sigma f. That means the sum of the f values. And when we add them, we're going to get 24 because it was stated in the question that the students are 24. So we're going to get 24 here. Now this is also going to be the sum of the fx. So we call that one sigma fx. So sigma fx, that means the sum of the fx, 144 plus 51 plus 144 plus 76. And after doing the calculations, you get 415. You can verify to see. We have 415 for the sigma fx. So why am I doing all this? I'm going to use this information, the sigma f and the sigma fx, to find the mean. That's a simple way to get the mean from a frequency distribution table. So now that we have this information, it will make it easier to even find the median and that of the mode. So let's go ahead and work each of them. So with the mode, you don't have to work anything. Mode is the most appearing data, so you don't have to work anything. So that's going to be question 1A, I. So obviously the mode is going to be 16 years, because there are 9 students who are aged 16. They are more than any other age. So we have 16 years to be the mode. Now let's get the median. So let's get the next one. That is going to be question 1A, II. That is the median. So we have 1A, II, the median. So the question is, how do we find the median from a frequency distribution table like this? Remember that the median is the middle number. So we are just looking for the middle age. So how do we do? How do we do that? There's a formula for that. Now, the formula is this. The median is equal to, half of sigma f th and next item. I'm going to explain this one. So when, the frequency is an even data. So we have 24, an even number. 24 is an even number. We use this formula. But when it is an odd number, it's going to be half of sigma f, plus 1 th item. So that is for, odd numbers. But for even numbers, we have this one because whenever the data is an even number, we get two middle numbers. That is why we have the next item here. It's not confusing at all. So let's see how we're going to, use this formula to get the median. Let's move on. So we have half into brackets, sigma f, which is 24, an even number. The th here is just trying to, give us the position. So th and the next item. So whatever we get here, the next item. So half of 24 is going to be, 12. Just attach the th. That is 12 item, the 12 item, and the next item. And now the next item is going to be what? 13th item. So you get it. So you have to know this formula. When we have an even data, we just use the formula half of sigma f and the next item. Now we just have to do the substitutions here like I've done here. You simplify to get your positions. So you have the 13th, the 12th and the 13th items. So those two numbers are going to be the median that we are looking for. Now, how do we get the 12th item and the 13th item? So that I just told you that these are just positions. So the median is not 12, the median is not 13, but rather it is giving you the position of the, the middle numbers. So the middle numbers are at the 12th position and the 13th position. So let's go to the frequency table here to look for those numbers. Now, this is what we're going to do. We just start from the frequencies from the top. We add, trying to get, 12 and out of 13. When we get to 12, we will stop and we know what to do. Get to 13, we also stop and we know what to do. So let's begin. So 9 plus 3, that's going to be, 12. So that means we will land here. And now, on this number, which is 3, it corresponds to, 17. So it means 17 is part of the median or the middle numbers. So that is the 12th position. It is 17. So we have 17 years. And let's see. So 9 plus 3 is 12. Plus 8 is going to be 20. Right? Now, 20 contains 13. So that means the 13th item is also within this 8. So we land here and look for the number which corresponds to that, which is 18. So the two middle numbers are, 17 years and, 18 years. So after that, we just have to find the mean of these two middle numbers. So let me work it here. This implies that the median is equal to 17 plus 18 or divided by 2. That is, we are finding the mean of the two middle numbers. So 17 plus 18, we're going to get 35 divided by 2, which is equal to, 17.5 years. You just have to know this formula. So when we have an even data, use this formula. When it is odd, use the other one that I gave. Do your substitution, simplify, look for your positions. That is all. Now let's get the mean. So the mean is going to be question 1A, I. So we want to find the mean. We know that the mean is denoted by this symbol X bar. So now, what's the formula for finding the mean from a frequency distribution table? That's very, very simple. So the mean is equal to sigma fx divided by sigma f. So now from this table, we have our sigma fx, which is 415. So divided by the sigma f, which is the total number of students in the class, and we have 24. So simplifying this one or dividing this one will give you the mean of the distribution. That is going to be 17.29. So you have 17.29, which we can, write it to one decimal place, and it's going to be 17.3 years. That is to one decimal place. Even though they didn't specify, you can also leave your answer as this. So that is it. That is how we can find the mean from this distribution. Now let's get to the next question. Question 1b. That's an interesting question. The table below shows the probabilities of 5 games played by 30 boys. So these are the games: football, hockey, volley, tennis, and basketball. These are the respective probabilities. So 0.35, 0.2, 0.05, and 0.25. And the first question is, find the probability that a boy likes basketball. This basketball, there is nothing here. They didn't give it the probability of basketball. So now we are going to look for that. So the question is, how do we do that? Yeah, that's a simple question. You should know that the total probability is going to be 1. So the total is equal to 1. Yeah, so when we add all these probabilities, it should be equal to 1. Now, there are 5. They are supposed to be 5, but we have 4 of them. So how do we get this one? We just have to add these 4 probabilities, and we subtract our answer from 1. And what we get, or what remains, will be for basketball. So that's a simple way to do it. So now let's do our addition, then we subtract later. So the probability of football, hockey, volley, and tennis, I'm going to use other for that. So I'm going to call that one the probability of other games. So that's going to be the probability of other games, and that is equal to 0.35 plus 0.2 plus 0.05 plus 0.25. So let me use the vertical form to add it here. So you have 0.35 plus, let me take 0.05 and 0.25. The next one is going to be 0.2. So let's add to see what we are going to get. So 5 plus 5 plus 5 is going to be 15. So we have 5, remainder 1. So 1 plus 3 is going to be 4, plus 2, that is 6, plus 2 is going to be 8. So we have 8 here, 0.0. So that's going to be, the sum of the probabilities of the other games. So we have 0.85. Now to get the probability of basketball, like I told you, we're going to subtract the 0.85 from 1. This implies that probability of basketball, I'm using B for that, is going to be 1 minus 0.85. Then what are we going to get? So 1 minus, let me do that subtraction here. We have 1.00 minus 0.85. So here's going to be 10 minus 5 is going to be 5. Here's going to be 9. 9 minus 8 is going to be 1. So here remains 0. We have 0 here. So that's going to be 0.15. The probability of basketball is 0.15. So let me get the last part 1 question here. That is question 1b II. So you have to find the probability that a boy does not like football. Now we know that basketball is 0.15. So the probability that a boy does not like football, what do we mean by that one? This is the probability of football, 0.35. So probability of a boy not liking football means we're going to subtract 0.35 from 1. And what will be left is that probability that we are looking for. Or you can add the remaining probabilities, 0.2 plus 0.05 plus 0.25 plus 0.15, and we are going to get the same answer. So an easy approach is this. The thing is that the total probability is always going to be 1. So if somebody likes football, then the reverse, which is not football, is going to be 1 minus, the probability of the person liking football. So that means that the probability of football, that one is here, is equal to 0.35. So probability of, the person not liking football, that is going to be probability of f prime is going to be 1 minus 0.35. So that's, a simple way to get the answer. So let me do the subtraction. So you have 1.00 minus 0.35. So subtract. So here is going to be 10. 10 minus 5 is going to be 5. Here remains 9. 9 minus 3 is going to be, 6. Point. Here remains 0. So 0 minus 0 is 0. So that's the probability. So P of f prime, that is not football, is equal to, 0.65. You can also use an alternative method, like I was saying, to, get the answer. You just have to add these probabilities. So let's try that one too here. So that's going to be this probability of not football. So that's going to be 0.2 plus 0.05 plus 0.25 plus 0.15. So in a vertical form, we have 0.05. I want to arrange it in a correct order. So we have 0.25, 0.15. The last one is going to be 0.2. So this is what we're going to get. Let's add them. So 5 plus 5 plus 5 is going to be 15. So 5, remainder 1. So 1 plus 2 is going to be 3 plus 1. We have 4 plus 2. We have 6. So 0. And you see we are getting the same answer, 0.65. So you easily subtract 0.35, which is those who like football, from 1 to get those who don't like football. So the same thing applies to, let's say, hockey. Those who like hockey, they are 0.2. That's their probability. So if you want to find those who don't like hockey, you just have to subtract 0.2 from 1. So the remaining is going to be those who don't like hockey. So that's a simple way. Now let's get the last question. So we have 1c here. And this is the expression we have to evaluate. 4 times 10 exponent 3 times, into bracket, 6 times 10 exponent negative 5. So that's the expression. So let's expand, let's remove the bracket here. So we're going to get 4 times 6 by 10 exponent 3 times 10 exponent negative 5. So 4 times 6 is going to be, 24 times. So I can use the loss of indices for these two guys. That is why I rearrange it like this, so that I can use the loss of indices for them. So you just have to take one of the bases, which is 10. And according to the law, when we are multiplying, we add the exponents. So that's going to be 3 plus neg 5. So that will give me 24 times 10 exponent. 3 plus neg 5 means 3 minus 5, which is going to be negative 2. That's the answer. But if you want to write it in an ordinary form, that's going to be, you just have to move. This is how we're going to write it. We have 24 here, multiplying 10 exponent negative 10. Exponent negative 10 means you're going to move to the left 2 times. So it's going to be like this, 1, 2. So the point is going to be here. So you have 0.24. So that is it. But if you want to show exact workings, it's going to be like this, 24 times 10 exponent negative 2. So that's the same as 24 times 1 over, 10 exponent 2, which is also the same as 24 times 1 over 100. Because 10 exponent 2 is 100. So we get, 24 out of 100. So you just have to move 2 times to the left, 1, 2, to divide it 0.24. So the answer is going to be 0.24. So that is it.